It's another exciting day in Algebra 2. Today we are going to be starting our solving polynomial equations, day 1, and we are going to be looking at the rational root theorem. But before we jump into that, I do want to review synthetic division with you because that is something that is going to be necessary for this particular topic. So, quick refresher, if I have a polynomial divided by a divisor with a degree of 1, meaning the exponent is 1, and a coefficient of 1, I can use my synthetic division where I'm going to set up my upside down house. The coefficients of my dividend are going to go inside. So that would be 4, 10, negative 25, negative 4. And then the opposite sign of my constant from my divisor will go outside. So because this is plus 4, I'm going to put minus 4 out here. And then the process for this synthetic division is that I'm going to bring down the leading term, multiply it by what's outside, so that gives me negative 16. Then I'm going to add to get negative 6 and repeat. Negative 6 times negative 4 is 24. Negative 25 plus 24 is negative 1. Negative 1 times negative 4 is positive 4. So this is 0, and this last number is my remainder, so I have a remainder of 0. And now these are the coefficients for my quotient. So starting with 1 degree less than my dividend had, starting with 3, so that means this is going to be 4x squared minus 6x minus 1 is the result when we did that division. And then if we had a remainder, we would put that as a fraction. So circling back now to solving polynomial equations. So when we have a polynomial, and we are going to be working with up to degree 3 and 4, meaning we have an exponent of 3 or 4, to solve them, the first thing that we need to do is find all of its rational roots. Now the way that we do this, and there is a small typo on here that I'm going to have you fix, I swapped which one is P and which one is Q. So your leading coefficient is Q, and the constant at the back is P. Why they're called that, I don't know. Ask the dead person who invented math. But we are going to figure out all of the factors of Q, all the factors of P, and then the results of P over Q are all of your possible rational roots. What that means is if I were to divide by that, I would get a remainder of 0. So we're going to identify all the factors of Q and P, find all of our rational roots, and then we're going to test them using synthetic division, which is why we reviewed that process at the beginning. And then any roots that don't give us a remainder of 0, we're going to eliminate. That one's not a root. That one's not a root. Once we find one that works, we are going to look at our quotient and repeat the process again until all we have left is a quadratic. So once we have a degree of 2, we are going to switch to one of our methods for solving a quadratic, being factoring if it's possible, quadratic formula, or completing the square. So that sounds like a lot, but again, we've got our checklist here. Let's start just by figuring out how to use the rational root theorem and go from there. So again, in this first function here, this 2 in front, that is our Q, and this negative 10 at the end, that is P. So what we first need to determine are what are the factors of all of those, both of those numbers. So Q. 2 has the factors 1 and 2. And for all of these factors that we're going to work with today, we are going to assume that we are referring to positive or negative. Because remember, I could do a negative times a negative to get a positive. So we could have plus or minus 1 or plus or minus 2. Okay. Now, P is negative 10. So what are all of the factors of 10? Well, we have, again, we're going to do plus or minus for all of these. 1, 2, 5, and 10. So, again, 2 has the factors 1 and 2, 10 has the factors 1, 2, 5, and 10. That is how I get my factors of Q and P. Now, all of the possible roots that this could be, P over Q, I am going to divide one of my P values by the Q's and get all of my rational roots, and we're going to eliminate the duplicates. So let's just go one at a time. I'm going to start with a P value of 1. So 1 over 1 would give me plus or minus 1. 1 over 2 would give me plus or minus 1/2. Now I'm going to switch to a different p-value. I'm going to look at 2. 2 over 1 would be plus or minus 2. 2 over 2 would be plus or minus 1, which I already have. That's a duplicate. So I'm going to move on now. My next p-value is 5. 5 over 1 is going to be plus or minus 5. And then 5 over 2, that's just going to give us a fraction answer, plus or minus 5 over 2. Okay, our last p-value is 10. 10 over 1 is going to be plus or minus 10. And then 10 over 2 would give us 5, which we already have. So these are all of my possible rational roots, meaning if I were to divide my polynomial by x plus or minus this value, I would get a remainder of 0 for one of these, or more than one, okay? Let's do that again. We're going to look at b now. Our q value is -6, and our p value is 9. So all of our possible factors for q, if this value is 6, again, we're going to say all of these are plus or minus. We have 1, 2, 3, and 6. Okay, and then for our factors of p, which is 9, again, we're going to say all of these are plus or minus. We have 1, 3, and 9. So all of our possible roots, p over q, are going to be 1 over 1, that's going to give us plus or minus 1. 1 over 2, that's going to be 1/2. 1 over 3, again, plus or minus 1/3. And 1 over 6, 1/6. Now we're going to move to p being 3. 3 over 1 is going to be plus or minus 3. 3 over 2, plus or minus 3 over 2. 3 over 3, that's going to be 1, which we already have. And then 3 over 6 is going to be 1/2, which we also already have. So we don't need to list our duplicates. Okay, last one, if p is 9, 9 over 1 is going to be plus or minus 9. 9 over 2, that's going to be a fraction, plus or minus 9 over 2. 9 over 3 is going to be 3, which we already have. And then 9 over 6 would reduce to 3 over 2, which we also already have. So these are all of the possible roots that we would use synthetic division to determine if they are actually roots or not. So now that we know how to identify possible roots, let's move on to determining if they are roots or not. We're going to use the rational root theorem to factor each expression. And now I am going to be using some scratch paper here because there's a lot of division that's going to be going on. So if you want to go grab some, go ahead and pause now to do so. So on the first one, if there's nothing written here, we're assuming that we have a leading coefficient of 1. So that means our q value is 1 and p is 8. So starting with all of our factors of q, if it's just 1, that's just going to be plus or minus 1. Now for 8, however, for my p values, that is going to be, again, plus or minus for all of these. We have 1, 2, 4, and 8. So for p over q, what that could possibly be, 1 over 1 is going to be 1, 2 over 1 is going to be 2, 4 over 1, 4, and 8 over 1, 8. So all of those values, plus or minus 1, 2, 4, and 8, could be roots. So what we want to do now is pick one to try. So again, this plus or minus 1 refers to x being plus or minus a value. So let's start with x plus 1 first. So I am going to see if x plus 1 is a factor, and I'm going to determine that with synthetic division. So I'm going to get my scratch paper to do this again, because we're going to be doing a lot of division here. So if I want to divide, again, this is x cubed plus x squared minus 10x plus 8. If I am dividing that by x plus 1, I can use synthetic division. And what I'm going to do, sorry, I'm sideways here. I'm going to set up my house with my coefficients. If this is plus 1, that means negative 1 goes on the outside. And I'm going to do my synthetic division. And I got a remainder that's not 0. So that means that this is not a factor. So x plus 1 was not a factor. So let's move on and try another one. So that was x plus 1. Let's try x minus 1 next. So I'm going to go back to my synthetic division. Sorry. Okay. So I'm dividing the same polynomial, x cubed plus x squared minus 10x plus 8, but this time I'm dividing it by x minus 1. So when I'm setting up my synthetic division, what goes inside is going to stay the same, but now positive 1 is going to go on the outside. Okay. And look at that. I ended up with a remainder of 0. So that means x minus 1 is a factor. And if I were to factor out x minus 1, what I would have left over is x squared plus 2x minus 8. So back to our original task at hand. We found a factor successfully, and what we have now is x minus 1 times x squared plus 2x minus 8. Now we're at a quadratic. That's what we wanted, right? Looking at this quadratic, negative 8 and 2. If I were to do my x method here, there are numbers that multiply to negative 8 and add to 2. That is going to be positive 4 and negative 2. So that means I can factor this trinomial into x plus 4 and x minus 2. And then bringing down that initial factor we took out at the start, here is my completely factored polynomial. Okay, so let's do that again for practice. We're going to look at b now. My q value is 2 this time, and p is 12. So all the possible factors of q, again, all plus or minus, is just going to be 1 and 2. For p, however, we're going to have a few more. Again, all plus or minus, we're going to have 1, 2, 3, 4, 6, and 12. So a lot more possible quotients here. P over Q, starting with 1. 1 over 1 is just going to be 1. 1 over 2 is going to be 1/2. Moving on to 2. 2 over 1 is 2. 2 over 2 is 1, which we already have. 3 over 1 is 3. 3 over 2 is going to be 3/2. Moving on to 4. 4 over 1 is 4. And 4 over 2 is 2, which we already have. Moving on to 6. 6 over 1 is 6. And 6 over 2 is 3, which we already have. And then lastly 12. 12 over 1 is 12. And 12 over 2 is 6, which we also already have. So here are all my possible factors, or rational roots. So now we are going to try one. Again, let's try x plus 1 first. So that's what we're going to try first. X plus 1. Divide that here just so we don't get confused on which one we're looking at. I'm going to try x plus 1. Let me get this written up here. 2x cubed minus 3x squared minus 8x plus 12. And we are dividing x plus 1. That is what we're trying with our synthetic division. Negative 1 goes out here. And again, I got a remainder that is not 0, so that one is not a factor. So let's try x minus 1. So now I'm going to divide by x minus 1 instead. Setting up my synthetic division. Let's see. And again, got a remainder that's not 0, so that one is also not a factor. So now let's try, let's move on to, I can't use a fraction for synthetic division, so let's move on to my next whole number, which is 2. Let's try x plus 2. And look at that, I got a remainder of 0, so this one is a factor, and it is about to cut me off, so let me rewrite the factorization, and I'm going to have to continue in a part 2, but this one did work, and when I factored out x plus 2, again, the result of my division tells me 2x squared minus 7x plus 6. Okay, come back for part 2.